Good morning, everyone. Just confirming, Sonali, that I'm audible for all the participants.
Yes, we are on.
Thank you. Thank you very much. So a very good warm good morning to everyone. I'm Thomas Spencer. I'm a fellow at TERI, and I have the great pleasure of introducing this webinar and then handing over to our speakers. So as you know, TERI has been doing a lot of work on energy transition, and this is really an agenda which is picking up steam globally on the back of some very impressive technology evolutions and cost reductions and so on, but also on the back of strengthening policy and concern about climate change. So today, together with Tata Consulting Engineers, we thought it would be a good idea to start a series of webinars on the industry perspective in India on energy transition, because industry is really the one with their ear to the ground regarding changing technologies and markets. So this is the first of these webinars, and thank you very much for joining. So I will just introduce our very august and experienced panel. I was reading through their biographies, and I think we have more than 250 patents and 200 peer-reviewed articles between them. So I think it will be a really interesting and rewarding time together this morning. So to start us off, we have Dr. Ajay Mathur, who will need no introduction, but I will give it anyway. Dr. Mathur is Director General of TERI. He's a member of the Prime Minister's Council on Climate Change. He was Director General of the Bureau of Energy Efficiency between 2006 and 2016. And he is co-chair of the Energy Transitions Commission, which is an international group of companies, major industrial financial players driving forward the energy transition in their respective sectors. Following Dr. Mathur, we have a keynote address from Sri Rajnath Ram. Mr. Ram is currently Advisor Energy at Niti Aayog. He's been working on government policy and program formulation related to oil and natural gas, renewable energy, power and coal. And he also leads the Energy Data Management Initiative of Niti Aayog, which aims to set up a data management system of international repute for India. And he also leads the initiative to set up an energy modeling unit at Niti Aayog. So we look forward very much to hearing from him. We will then have a panel discussion with our industry participants, and I will just briefly introduce them. This discussion will be chaired by Dr. Mathur. In our panel, we have Mr. Nitin Prasad, who is Chairman, Shell Companies of India. Mr. Prasad is a Fortune 40 Under 40 awardee. He succeeded as Chairman of Shell Companies in 2016. And before that, he was Managing Director for Shell Lubricants for India, Sri Lanka, and Bangladesh. And we look forward to hearing his perspectives on the energy transition in the fuel sector and the transport sectors. We have Mr. Ajoy Behari Lal, who is responsible for operations at 5 manufacturing facilities of Tata Motors India. He has over 35 years of experience in the automotive industry at different locations across India, and a degree in mechanical engineering from Motilal Nehru National Institute of Technology, Allahabad, and an MBA degree from XLR Jamshedpur. So we really look forward to hearing from Mr. Lal regarding the emerging transition, particularly towards electric vehicles and alternative drivetrains in the transport sector. We also have Dr. SSV Ramakumar, who is Director R&D on the board of the Indian Oil Corporation Limited. He has more than 3 decades of R&D experience in the downstream hydrocarbon sector, notably in the area of lubricant technology, refinery process research, and catalyst development. And I think we all understand that the energy system will continue to need liquid fuels, will continue to need hydrocarbons for some time. And so how we reduce the environmental footprint of these fuels will be something that we look forward to hearing from Dr. Ramakumar. He will be followed by Dr. Devishesh Bhattacharjee, who is Vice President of Technology and New Materials at Tata Steel. He's setting up non-steel businesses such as composites and graphene at Tata Steel, and oversees technology and R&D in Tata Steel. And the steel sector is really one where previously the optimism about options for reducing emissions was maybe a bit less, but we're really seeing some interesting technology developments there. So we look forward to hearing from him on that. He's an alumnus of Javadpur University, has done his MTech in IIT Kanpur, and has a PhD in materials science and engineering from the University of Cambridge. And last but not least, we have Mr. Ahmed Sharma, who is Managing Director of Tata Consulting Engineers Limited, India's largest private sector engineering and project consultancy. Before becoming MD, Mr. Sharma was Executive Director and Chief Operating Officer of Tata Consulting Engineers from 2012 onwards. He has a rich, long experience in the private sector. He was Resident Director of Adkins India Private Limited, a global engineering and design firm, prior to his stint at Tata Consulting Engineers. And his perspective spans so many sectors that I think we'll really get an interesting insight from him. So with my introductory duties done, I will hand over to Dr. Ajay Mathur to give the opening address and to chair the panel after the two keynote addresses. Over to you, sir.
Thank you very much, Thomas. First of all, it's such a pleasure to welcome all of you to this webinar. We note that we have over 350 people registered, and I look forward to a stimulating discussion here. As Thomas mentioned, this panel is a broad panel in terms of sectors, and what we are looking at is the energy transitions that we see happening in India and the kinds of industry-led initiatives that fit themselves into this larger transition. We also am delighted to welcome Mr. Rajnath Ram, who has very, very kindly agreed to be with us and to share a perspective on how the policy changes are looking in view of this energy transition. I want to thank in particular Tata Consulting Engineers, Ahmed Sharma, the Managing Director, for this partnership, and we hope that we can move ahead quickly in this area and provide leadership as far as India is concerned in taking advantage of this energy transition that is not only happening in India, but is happening across the world. I also want to thank Mr. Nitin Prasad for joining us. Nitin has been, let me say, a co-conspirator in pushing the energy transition agenda ahead. And, you know, for a large oil player to start thinking about an energy transition is a big issue. And I'm absolutely delighted that we have Nitin with us and also Dr. Ramkumar. Dr. Ramkumar heads R&D in Indian Oil, and his views on how we are looking at the future would, I think, be extremely important to us. One of the areas that we are looking at as far as changes are concerned is the transport sector, and I'm delighted that we have Mr. Joy Lal from Tata Motors with us, who have been a leader in introducing electric automobiles. And of course, Amit, I look forward to see how we can wrap this around, how companies can move ahead into this energy transition future that we see for us. What I'd like to do is, from our point of view, from TERI's point of view, share with you not 10, but actually 9 messages. These are key of the kinds of findings that we have had over the past 2 or 3 years, as Thomas mentioned, regarding the moves that we see with effect of both our demand, the way it is changing, but also the supply side and the kinds of technology and performance parameters that we are seeing happening not only in India but across the world. The key message that I think I want to share is that as we look to the future, and I hope the PowerPoint is visible now. Is it, Amit, just raise your hand if it is visible. Okay, great. No. Is it?
It is open, sir, but you had minimized the screen that it was
okay.
in. Yeah,
Okay.
that's it.
Is that okay now? Okay.
Now you have opened another one.
No, something else. Here we are.
Yeah, that's
Fine.
it. You can just, yeah.
I'm sorry, technological change is not as easy as we would like it to be. So the main message that I think all of us need to carry is the dramatic cost declines in low carbon technologies that have happened and continue to happen. Now, this is because of various reasons. It's because of the R&D that has happened across the world in very many sectors. It's also the huge emphasis that is being placed on the introduction of low zero carbon emission technologies. And together they've created an environment within which it is now cost effective to move towards zero carbon technologies. I think the point that is to be made is that whereas for fossil fuels we have seen prices that are largely increasing, in some cases in gas particularly they are declining, but the declines that we have seen in oil, in PV and wind have been dramatic, and these are still continuing. You would note the tender that was floated by the Solar Energy Corporation of India a few days ago, where they found a price for the delivery of solar electricity at less than 2 rupees, 1.99 rupees per kilowatt hour. This dramatically changes the kind of future that we see. Electricity, solar electricity is already the cheapest electricity that we have in India, but only when the sun is shining. And that leads to the second message, which is that the RE, the renewable energies, because they are variable in inputs, that means when the sun is shining or the wind is blowing, we have renewable electricity. We are looking at the need for the power system to greatly enhance its flexibility. So when the sun is shining, we are able to integrate renewable solar electricity, and when it is not shining, then either today we use the electricity generation sources that are there, largely coal, but that means that the coal power will have to ramp up and ramp down. And over a period of time, as more and more solar comes in, we also build up storage. And again, the issue of cost effectiveness of storage is a key challenge. How quickly does a storage reduce in price? The Solar Energy Corporation of India tenders tell us that in 2 years, we will have round-the-clock electricity, solar plus batteries, at prices that are competitive with coal. The third message that I'd like to leave you with is that even if you consider the sunk costs, the electricity contracts are done in a very particular way in India, where the distribution companies pay for the sunk costs, for the capital costs of coal power stations, whether they buy any electricity or not. And then they pay a variable cost, which is largely the cost of the coal itself, based on how much electricity they actually. So if you compare with variable costs and then see what system cost, we see that the system cost is at about 4.5 rupees per kilowatt hour, and the renewable prices are such that way over 60% can be cost effective even today. I think this is an issue that all of us need to internalize as we look at our electricity procurement plans in the years to come. However, if we look to the future, and we're looking not at 2020 but 2050 costs, we are looking at a system cost that is cost effective at more or less the same price as it is today. Now, this is a crucial issue because what this means is that even with the storage built in, we are able to meet 100% of the demand from wind and solar. This has huge repercussions in terms of what are the new capacities that we add tomorrow. Do we add more coal or gas? No, it doesn't make sense. If we are looking at a future in which even with the storage, we will be able to have costs that are less than those of the existing technologies, then it just doesn't make sense to invest. So again, as far as tomorrow is concerned, we are looking increasingly at more and more and more renewables coming in till the system is fully carbon free. The fifth message is, because of this transition, because the electricity is moving towards more and more renewables, this means that the emissions from the power sector decrease. And what it implies is that the emissions from the transport sector and the industry sector become the largest source of CO2 emissions, and hence our emphasis therefore shifts to how do we move to zero carbon in the transport and industry sectors. This is a bit of a challenge. It is a challenge in as much as there are many, many applications which can be electrified. For example, transport, we can move from fossil fuels to electric. You can also move from fossil fuel to hydrogen. But there are still some sectors, and steel, and we hope to hear from Devishesh in a little while, there are some where it is challenging. There are emerging new technologies in which coke, and therefore use of coke in steel making, which necessarily produces CO2, could be replaced by hydrogen for reduction. But it's still a demonstration plant. If you look at cement, we actually don't have a technology, because when you calcine calcium carbonate, CO2 is an inevitable byproduct. And short of capturing that CO2 and sequestering it or using it somewhere else, we do not have a technology choice. So I think the emphasis on industrial and transport uses becomes a lot more important, I would suggest even now, because the renewables and the batteries revolution in terms of its performance and price is something that is ongoing and will continue. So as we look at the transport demand, I think it is important to separate out both freight and passenger. And if we do that and we look at the kinds of fuels that can be used, we are looking at fossil fuels still being used in 2050. But an increasing amount of electrification occurring, some amount of hydrogen being used, and some amount of natural gas being used. Now, this is on as-is basis. Obviously, if you have got huge changes in the economic performance of electricity and hydrogen, these could change. But we are looking at a future in which there is an increasing amount, particularly of electricity use. We have been very challenged about where will hydrogen be used in transport, which is an issue that we continue to work on. And please stay tuned for further analyses in this area. Right now, we believe that electricity heavy-duty trucks may be cost-effective using electricity. There are advantages of hydrogen. It is available through pipelines. It is available through the current petrol stations, and consequently, it is not very clear whether economics alone will be able to flip the longer term, the long distance road transport to electricity alone or to electricity and hydrogen. But as I said, this is an area in which we are still waiting to see how technology evolution occurs. The eighth message is on hydrogen. Today, hydrogen is largely used in refineries and is used for ammonia production. And this is largely obtained from steam reforming of methane, which is at a cost of about $2 per kg. What we see is that with current solar costs, we are looking at a price of hydrogen, which is about $5 per kg as compared to the $2 per kg, and an ammonia price, which is instead of the 23, 20 or 25 or 26,000 rupees per ton, it comes out to be somewhere in the vicinity of 32, 33, 34,000 rupees per ton. However, as electrolyzer costs decrease, and as the costs of electricity from renewables, from solar decreases, we see that this price of hydrogen decreases and reaches and then goes below the $2 per kg price that we have from the steam reformation of methane. And therefore, we are looking that possibly as quickly as 2030, but certainly before 2035, hydrogen would become cost effective. We're also looking at the use of fossil fuels. I should have said this in the previous slide. When you're looking at transport, if you look at a place like Ladakh, the price of diesel transport there is very high. You add typically 40 to 50 rupees a liter in moving diesel from, say, Chandigarh and airlifting it to Leh. In those circumstances, locally made hydrogen becomes more cost effective. So it is this kind of variability that we will start seeing as we look to the future. Is that if we have more electricity use in transport, if we have more electricity use in industry, a lot of heating applications, except very high temperature applications, would possibly move to electricity. And we are seeing that homes start using more electricity. There's greater commercial growth where ACs and are used and lighting is used. All of this will lead to greater electricity demand. And we therefore develop sector-specific models to look at the demand. This is very, very doable. The amount of electricity generation capacity that we have and the amount of addition that we have due to solar and wind would more than adequately be possible to meet the growing demand, as we discussed earlier, at cost-effective rates. This is what we are seeing. And therefore, whether you are looking at inputs or you're looking at the outputs which industry produces, steel or ammonia or whatever, or transport, we are seeing that there is a cost effectiveness. But as we go ahead, how this transition moves would largely depend on how we see the kinds of infrastructure, the kinds of investments that occur now, because investments made now have a long lock-in period. I'll end here, and I look forward to Mr. Rajnath Ram's talk on how we are looking at the policy as far as energy is concerned, and then I look forward to hear our colleagues from the industry on how they are looking at both energy generation and energy use in the future. So with that, let me turn it over to Mr. Rajnath Ram and request him to share his thoughts with us.
Thank you, Dr. Ajay Mathur. Am I audible?
Yes.
Yeah. So good morning to everyone, and good morning to all the distinguished panelists here. I would really thank TERI for organizing this event, Energy Transition Pathway in the Indian Industry, towards our collective commitment to deliver green energy for all. Let me, at the outset, let me congratulate Dr. Mathur. He has already set up the context. So I'll be talking something very different. Already he has raised several issues. And the policy perspective angle and the government views on the different contexts of the energy transition. So I'll be briefly touching on those aspects. As we know that we have already on the pathways of meeting our nationally determined contribution target to achieve the 40% of the installed power generation capacity through the non-fossil route, and meeting the emission intensity reduction by 33 to 35% by 2030 from the 2005 level. India has been rolling out multiple initiatives, programs, policies, and incentives to accelerate the deployment of the renewable energy sector. That's the major push that the government is taking up. But at the same time, we also know that the several ambitious targets had been set up by the government, like 175 gigawatt target by 2022, 450 by 2030. Although it has been recognized that COVID-19 has led global economies to put them on the back foot, and so the India is. But we have to act now by strengthening our domestic capability and thereby achieving energy security and driving economic recovery implementation, because this is very critical. Let me bring this aspect of the industrial decarbonization. Globally, more than half of the global CO2 emission results from the manufacturing side, particularly 4 industrial commodities, and that are the ammonia, cement, ethylene, and the steel sector. This also holds true for the India, where iron, steel, cement, ammonia, and the chemical, primarily the petrochemicals, together contribute nearly about 70% of the emission from the country's manufacturing sector. Thus, industrial decarbonization is very critical, and unless the adequate investment in the low carbon technology is channeled, we need to utilize the global scale for reducing the cost of zero carbon industrial equipment and bringing them at par with the level of the existing high carbon design. We can go for even electrifying the industry, and we must incentivize them. So this is the broad thinking. I think the government is thinking on those lines. With respect to the power sector, as we know historically, to meet ever growing electricity demand, India has been targeting to add large scale conventional power capacity. But today coal contributes roughly about 72% of power generation of the country. But now with the technology disruptions and the becoming competitive of this renewable, like solar and wind, in comparison to the other mainstream sources, we have the additional choices available. So the future power system really need to be looked into very seriously. Solar deployment has been a flagship green growth story for the last half decade, and will be instrumental in stimulating the growth and building the climate resilient world. Solar PV manufacture, although we have a very limited capacity of solar PV manufacturing, but that capacity we need to certainly increase. India is looking at implementing various supply and demand side interventions for manufacturing of the solar cells wafer ingots and make India a global hub for the solar PV manufacturing. And currently, India has announced this performance-linked incentive program, which is likely to give a boost to the domestic companies. And the cabinet has already approved in the initial phase for providing with the rupees 4,500 crore of high efficiency solar PV module manufacturing. In August, government already announced plans to offer land in the near to its ports to companies for building solar equipment factories. As a result, government measures to achieve the Atmanirbhar Bharat as per the MNRE, already EOIs for the 20 gigawatt of module and the cell manufacturing have been issued. The emergence of hybrid renewable storage projects for round-the-clock power at a levelized tariff lower than the thermal is expected to further accelerate the clean growth. Further, India has poised to announce its national hydrogen mission. India's large coastline provides opportunities for the hydrogen production from the seawater. Also, hydrogen is one of the leading options for the storing energy from the renewable, and also looks promising to be a lowest cost option for storing electricity over days. Conversion of solar electricity to the secondary energy carriers such as hydrogen and its derivatives such as ammonia may be a relevant option to achieve continued system integration. On the other side, as a part of clean energy transition, we are also looking to have the relatively cleaner options into the system. We are also poised to increase our gas share in the overall energy basket, and already government has announced increase its share from 6% to 15% by 2030. But that also need to be assessed very carefully because a lot of challenges will be posed due to technology disruptions already happening. Now electric vehicle is becoming commercially viable. I mean, it is now going to within the reach of the common people. So the gas sector in particular, they have to really find out the business in the sense, because if you see the city gas distribution network, the major share of their business constitute of the CNG, and which goes to the transport sector. If that disruptions happen, then we have to really find the new avenues for the gas sector. Power sector itself is not becoming viable because we are based on the imported LNG, and the price is fluctuating like anything. So we don't have any very stable pricing regime where you can really think of making the power sector more economical and viable. So the sectors really remains with the gas sector is the clean cooking aspect, where we can think of replacing the part of the LPG and making it available to the industrial sector where the decarbonization activities can be taken place. We have also targeting to go for the biomass production, bioethanol, compressed biogas, and we are now targeting from the domestic sources a 20% blending, although it was a target earlier 2030, but now the government is planning to advance it back by 2025. So I think lot of activities is happening within the government, a lot of technology interventions. So we have to really think that this energy transition is not very easy, as there is a rapid technology disruption happening. So we really need to have a very strong coordination within the government and within the existing stakeholders and keeping everybody on board, because the technology intrusion will really certainly have to have some kind of trade-off within the existing energy paradigm. So a very strong coordination is required within the government and within the stakeholder industry, academia. Everybody should be on board, so that it should not be like that we include and pursue all the technology options and the industry really get disturbed. So with this remarks, I really thank TERI for inviting me here. Thank you.
Thank you very much, sir. Very interesting remarks to hear the perspective of the government and the policymaker. I would now hand over to Dr. Mathur to chair the panel discussion and take us forward. I think you are not audible, sir. Sonali, can you just see if you can unmute Dr. Mathur?
Sir, can you please unmute yourself?
Okay, I think yes.
Yeah, we got you, sir.
Many thanks. Yes, great. So many thanks, Rajnath, and I think this is an important view, in as much as we are looking at the longer term growth of renewables and batteries being supported through the performance-linked incentive programs, the even longer term interest in hydrogen being supported, and in the short term, thinking of gas as a bridging fuel. I would, however, suggest that this is very much a matter of economics, and if we want to have infrastructure that is not locked in, then we would need to see where is it that hydrogen can come in, and in those areas gas comes in today. You have the infrastructure that is built for gas can be used for hydrogen tomorrow. But without further ado, let me request our panelists for their thoughts, and let me start with Nitin. Mr. Nitin Prasad, the floor is all yours. I think, again, in my case, what had happened was that I was said to be muted by the organizer. Please make sure that Mr. Nitin Prasad is unmuted.
Mr. Prasad, can you try once again, because it is unmuted from my side, sir?
Hi, good morning, everybody, and
Yes.
I think our journey with digital technology continues with every new system. So let me also begin by wishing a very good morning to all my fellow panelists and a very happy New Year. It's wonderful to see everybody again, and I think it's worth sort of commenting and starting with a recognition that this could actually be shaping up to be quite a significant year. And in as much as 2020 was defined as a year with the pandemic and COVID, I think what is looking forward is that 2021 may be a year that is defined on climate change. And that brings in itself a tremendous sort of step forward in terms of what the way we need to think about this. One of the things that Dr. Mathur sort of teed up very clearly was the sense on what does the transition start to look like for companies such as ourselves. And I think there's been a lot of sort of discussion to say that whether the COVID and the economic crisis is going to come back and slow the transition going forward. And I think it's worth highlighting that actually what we did is back in April of 2020, we upped our ambition. So we increased our ambition in terms of what we will come back and do in this space. And just to sort of characterize what that looks like, we came back very clearly and said that we are committing to be a net zero company by 2050 in terms of all the emissions that we produce from the manufacturing of all of our products. And Mr. Ram, of course, made a comment about the ethylene side of the production. We are one of the largest producers of ethylene in the world. Equally, what we've come back and said is that we have an ambition to work on the carbon intensity of all the products that we sell. And this is quite an important point because what it connects to is the scope 3 aspect of the emissions. And scope 3, which is the emissions associated with the usage of our products by customers, is actually 85% of all the emissions associated with our industry. So this is all the fuels that are burnt in cars and vehicles and planes and or in all the industrial activity. And really important that we came back and suggested that we will work on working on reducing the emissions of the products that we sell so that we work effectively in reducing the scope 3 emissions moving forward. And that is a significant challenge going forward. And the third aspect on this one was to work with customers and to be quite clear on the customers that we choose to work with in terms of decarbonizing their products and solutions going forward. And that leads me to, I think, 2 or 3 words that I think are going to define the energy transition for the hydrocarbon industry. And let me just put them forward and pull that storyline together. The first is flexibility, actually. And so people who are sort of hoping to hear things like digitalization and so forth, I actually don't think that is going to define the transition that we're going through, but it's actually going to be flexibility. And what do I mean by that? If you take a look at the way that the energy industry is currently structured, we typically have consistent commoditized products and sets and services that we offer to customers. But going forward, what we're seeing increasingly, as you take a look at the industrial space as an example, what is needed is to be able to work very closely with customers to develop the decarbonization solutions that are fit for purpose for their particular use case and application. And that tends to be variable, not just on a sector by sector basis or a customer by customer basis, but it can be quite variable on a site by site or a plant by plant basis going forward. So what is necessary is more in the industrial space is to be able to come back and create the basket of solutions and products and services that are going to be available. But equally, we develop the process and the methodologies and the system models to be able to come and make the selection of the choices from the menu that we come back and offer. So that may come back and suggest that there are steel plants, and this is work that we are actually doing, who may suggest that they have a preference for biochar as being one of the solutions that they would like to deploy because they are able to make it cost effective. Or equally, there may be a steel plant who is right next door who will come back and suggest that they would have a preference for a gas-based solution, or another one that would prefer to choose electric arc furnaces and have a lower cost of electricity. And all of these are choices that we need to come back and provide as an industry. But equally, we need to be able to help and support our customers in making these choices as they define their decarbonization pathways. So to co-develop and co-create the pathways as we go forward. Equally, choice is going to be quite important in consumers and customers as we talk about mobility solutions. Because the reality is that the use cases of a mobility solution define what a customer comes back and chooses. So can we suggest, for example, that a two-wheeler in an urban context using their bike or scooter for commuting would have the same use case as a rural two-wheeler who potentially may be using actually their two-wheeler vehicle for goods movement or multiple passenger movement. You have very different power requirements, different ratio requirements, different use cases. And effectively the solution, the decarbonization solution that is necessary there is in itself going to be quite different. So the challenge comes back to us as mobility energy solution providers, is how do you provide for a range of different customer use cases and applications across all of the industry. For example, even things like tractors. And we can't forget that tractors is one of the largest consumers of diesel in the country. And that, by the way, they're also used for transportation and mobility. So flexibility is the first word that is going to be a challenge for us as an industry. And here, of course, they come back and say, how do we do this? Well, this is where I think digitalization actually fits in. And digitalization as the enabler for the energy transition, it is the tool that helps us provide the flexibility. It is the tool that allows us to scale these solutions and make it more cost effective and effectively provide disaggregated sources of energy solutions for customers and consumers going forward. We can speak more about that a little bit further, but I think it's quite important that the context on that one is clear. The second thing that's defining our industry going forward is the need to collaborate. And the reality is that we do not have all the solutions, nor can we develop all the solutions ourselves. And what is increasingly emerging is the need for us to collaborate with our partners and our suppliers and start to work backwards into their particular supply chains and start to see how do we start to work on decarbonization of them. As one of the largest procurers of steel in the world, we need to actually come and work with our partners who actually where we procure the steel from to help and decarbonize them. But equally, in order to provide the digitalization, the solutions, the low cost-effective solution, we have to start working with the project management consultants, with the EPCs to say how do we start to integrate the digitalization of all of these solutions as we go forward, because the way that we've been doing this is too time consuming and it's too costly at this point as we go forward. So we've been quite proud to work with on a number of different platforms in this particular space. With Ahmed's support and Dr. Ajay's support, as we said, we were a co-conspirator in the industry coalition that was created, and it's a wonderful platform, I think, for us to take these conversations forward. And equally, we've been a big supporter of the agreement between the Embassy of Netherlands and Niti Aayog in terms of taking a look at the decarbonization solutions and the agreement that was put forward there. We must go out and support startups, and we have our incubation platforms and other platforms and things that we do in that space. So this is about working across all aspects of the industry and collaborating with all of the different stakeholders, government to policymakers to think tanks to startups to different customers to other multinationals, and be able to pull those together in a way that we all work together and collaborate to be able to put these solutions forward. This is going to fundamentally challenge many different things, such as intellectual property, such as how do we work together, legal frameworks, contractual frameworks, etc. But these are the things that we are effectively working our way through. The last word I think is we talk about the energy transition for a hydrocarbon, but actually this is about an energy transition acceleration. And I always feel that we miss this third word in this particular storyline, because what we need to come back and do is actually to accelerate the energy transition. Now, history will tell us that energy solutions have a gestation period of about 30 years. The first solar plant was actually in the 1980s in California, and it has taken us this long to get to this point. And at one point in time, Shell was actually one of the largest producers of solar panels in the world, and that was the business that we were in, and we subsequently sold that business. But we do not have 30 years left to get the next wave of technologies onto the table, whether it is CCUS, the utilization aspect of it for sure, whether it is the plastics pyrolysis or the utilization of plastics, biofuels, and how do we come back and create next generation biofuels, 2G to advanced biofuels, and other sort of, hydrogen, of course, was mentioned a couple of times over. We do not have 30 years. So the challenge here is how do we accelerate the energy transition through all the work that we come back and do. And this is about utilizing the collaboration and the tools and the partnerships that we create to be able to do that going forward. So to summarize, and we can speak more about this as we go forward, I see three key words as defining the energy transition for the hydrocarbon industry: flexibility of choice, collaboration on how we work with our partners and vendors, and the energy transition acceleration. And this would allow us to come and emerge. And if you talk about a future that emerges, what does the energy system start to look like in the future? I think has been very accurately portrayed by Dr. Mathur and Mr. Rajnath Ram. But you can imagine that it is no longer fossil fuel dependent. Fossil fuels don't go away, but they are present, but it's not dependent on it. But you're starting to see hydrogen systems emerge, and hydrogen systems that could be in clusters or disaggregated. You see connectedness between different systems. So for example, one of the projects we're doing is working with Eneco and in a partnership that we just announced to have an offshore wind platform in Netherlands and take the electricity that's generated and put in a 200 megawatt electrolyzer in the port of Rotterdam to then come back and use that for the industrial customers there, our own refineries, but also for transportation solutions. So you're seeing new structures being created in value chains and in terms of how we work together going forward. You can imagine that things like as you start to create hydrogen systems or CCUS, there's no one plant that can necessarily use these systems, and you have to start to see that there will be clusters of companies that will naturally come together as byproducts get created and new product streams get created, and you see new things that need to be put together. So new groupings of industries have to come together to be able to take this forward, and so on moving forward. So I think to summarize, for the hydrocarbon industry, our role will be to accelerate the energy transition through collaboration and provide customers the flexibility of low carbon fuel choices moving forward. Thank you.
Thank you very much, Nitin. And I think your point about each company needing to find out what needs to do and us having a framework, I think highlights the importance of the response to this transition that has happened. Let me now turn to Mr. Ajoy Lal, who represents a company which has been in the forefront of transition, to share his views and thoughts with us. Ajoy.
Thank you. Am I audible?
Yes.
Great. So that's one challenge surpassed. So good morning, everybody. And my compliments to TERI and TCE for having organized this. I think it's very well thought out. And thank you also, Amit and everybody, for having me here today. So I think Dr. Mathur has actually made our job very easy. He talked about transportation industry, and so let me just take on whatever Dr. Mathur just mentioned in his speech. Transportation sector really represents 23% of all energy-related global emissions, and as responsible corporates, organizations have taken targets which are aligned to the commitment made in the Paris Agreement 2015, and by using tools like SBTI, which is Science-Based Target Initiative, to ensure that we all play our equitable role in limiting the temperature rise to 1.5 degrees centigrade till 2050. In case of automobiles, more than 90% of total life cycle CNG emission associated are from scope 3 emissions, and 80% is around 80% is actually running emission. Therefore, automobile companies or OEMs need to continue focus on evolving their product portfolios to make emission-friendly ones by leveraging improved efficiency, mileage, use of cleaner fuels, CNG, LPG, hydrogen. Some of these got talked about by the previous speakers. And of course, migration to EV with continued development of more economically accessible and value-driven electric vehicles. Automobile OEMs also need to continue to improve the overall carbon footprint of their own operations. This is about scope 1 and scope 2. Although their contribution is only 20%, but it actually helps to send a signal and a message across the organization and through the employees of the organization across the ecosystem. And therefore, the focus on scope 1, scope 2 is equally important. And this is mainly by improved operational efficiency in terms of power and fuel utilization, use of technologies which enable lower power and fuel consumption. There are several, for example, variable frequency drive, LED, heat recovery systems, regenerative drives, etc. Digital intervention for automated monitoring and analysis of power and fuel consumption. I think Industry 4.0 is a big enabler here. And captive capacities for solar and wind power. So just to give you an understanding, for example, in Tata Motors, we use about 22% of our energy at the moment from renewable sources, and there are plans to really multiply this going forward. And some of the initiatives that are taken in the company for scope 1 emissions are waste heat recovery systems, adoption of innovative technologies such as heat pump in place of electric heating, HVLS fans, electrical paint circulation systems, etc. Process automation and Industry 4.0 projects. In fact, there are several such things, especially in energy consumption areas like paint shop. LEDs is commonplace for offices, shops, and street lights. VFDs for screw compression, fanless cooling towers, twin ventilators, insulated roof walls of the shop, of daylight panels, solar light dome, etc. Now, coming back to scope 3 now, the global e-mobility industry is actually...
What is this about?
Is it... can I go on? Am I audible?
Yes, please go on. Yeah.
Yes, you're audible. Yeah, I could hear some voice. It's okay. So the global e-mobility industry is facing a lot of challenges as it matures in terms of product price, which is significantly higher than ICE vehicles. So it's still about 1.5 to 3 times the price of ICE vehicles. Higher charging time compared to conventional refueling. All of us know that the minimum it takes is 20 to 25 minutes to charge the battery, and whereas we all know how much time it takes charging the fuel. Low density of charging infrastructure currently. The current density of charging infrastructure is quite low compared to conventional gas stations. So if I have to give you an example from Germany, for example, if it has 14,000 gas stations, it has only 2,000 charging stations. So that's the kind of penetration of infrastructure as of now, even in developed economies of Western Europe. Safety risks in terms of battery management, these are more perceived risks, but yes, we have had 1 or 2 incidents. For example, the recent accident of a battery burning in a Tesla Model 5. I mean, these are odd, but I think these do build perception. Vehicle range significantly lower than ICE, and so this is also an important consideration, especially for commercial vehicles which go on the long haul. Coming to the technology of EV industry, actually pegged with the development and evolution of the various battery technologies and eventually fuel cell technologies. It also got mentioned by Dr. Mathur. So among the various lithium-ion battery technologies, nickel, manganese, cobalt appears to be the most well-rounded technology with respect to specific energy, cost, safety, specific power, performance, and lifespan. While FCV technology is farthest from market maturity and also currently the most costly, it has its advantages in range and recharge time, which are currently inhibiting factors for battery vehicles. While challenges are foreseen in second life of batteries, applications outside automotive sectors can be viewed as a potential business. Recycling of batteries would also be critical for India to keep the import dependency minimum in view of India having limited reserves of special minerals used in cells. So in fact, this is one of the challenges, and I understand the Western world is now also looking at alternate materials so that it can reduce their dependence on just one geography of the world. So this is on the technology side. Also, if you look at the ecosystem of automobile sector, automobile is largely depends on ecosystems of suppliers and dealers. So coming to suppliers, most of the setup that they now have will have to get realigned to the EV ecosystem. So they actually, many of these vendors are working on expanding their capabilities in different IC technologies to those needed in EV ecosystem. For example, cooling system suppliers are working on upgrading to thermal management for batteries. Raw material mix, is also going to change, and my friend from steel industry are there. So steel is going to actually come down from maybe 55-60% to 50-55%. Active materials are going to go up compared to almost nothing today. Aluminum is going to go up from, let's say, current 3 to 4% to 7-8%. And therefore, I think the industry is well aware of all these changes, and some of them are actually trying to align and transform themselves into so that they fit in the EV ecosystem. To give you one or two examples, casting and forging suppliers are aligning their portfolio towards suspension and brake systems. They are also venturing into motor housing, for example. Powertrain pump suppliers are venturing into battery and electric cooling systems. Precision powertrain component manufacturers are using their expertise in precision manufacturing for electric powertrain components and things like that. So the industry is actually, the ecosystem is actually fully aware of where the shift is going to take place, and many of them have actually started working towards this. And finally, I think this, of course, all of us look at the government, which has a critical enabling role in successful growth of EV industry. The FAME 2 scheme by the Indian government has made EV economically competitive to the ICE counterparts. For several section of auto market, for example, buses, LCVs, and four-wheeler commercials. Several state governments have also rolled out their policies which encourage faster growth of EV in their respective states. Development of versatile charging infrastructure which will be able to cater and support the various technology while defining set of standards for industry to follow. And in order to make EVs more eco-friendly compared to ICE, our grid mix also has to get skewed towards renewable energy, hydro, solar, wind, etc. This also got talked about by the previous speakers. And finally, I just wanted to mention about the FAME India scheme phase 2. I think this has been a fantastic catalyst in the growth of EV industry. Government has actually approved phase 2 of FAME scheme with an outlay of rupees 10,000 crores for a period of 3 years, commencing from 1st April 2019. Out of total budgetary support, about 86% of fund has been allocated for demand incentives, which is very, very critical, so as to create demand for the EVs in the country. The phase really aims to generate demand by way of supporting 7,000 e-buses, 5 lakh e-3-wheelers, 55,000 wheeler passenger cars, including strong hybrid, and 10 lakh two-wheelers. So therefore, there are a lot of things falling into place, and I can see this energy transition accelerating, as Nathan mentioned, quite fast in automobile and transportation sector. Thank you.
Thank you very much, Mr. Lal. I think the kinds of interventions across the board that have been made by Tata Motors reflect the kinds of holistic changes that companies would need to make as they move to a transition. The challenge, of course, is what do you do now, what do you do tomorrow, what do you do the day after? So let me now turn to Dr. Ramkumar and request him to share his thoughts on how they are looking at the energy future of tomorrow.
So thank you, Dr. Mathur, and good morning to all the fellow panelists and the participants. I thank TERI and TCS for giving me this opportunity to be amongst this august panel to share my views on this very important and contemporary topic of energy transition. See, coming from the largest oil refining and marketing company of the country, we are quite aware that today the fossilized carbon dioxide emissions, today they are hovering at around 40 gigaton or 40 billion tons. And if the business as usual scenario continues, then by 2050 it will go to 60 gigaton. This is what is estimated, from 411 ppm ambient CO2 content of today to just double, 850. So to fix this conundrum and to contain the global warming or Earth's temperature rising, then not one single solution is there. And especially for people like us who are in the fossilized business today, not one single solution really is going to address this enormous problem. That's what we realize. And we want to go for a wedge approach where there are several wedges in which one need to work. To just take the analogy of Princeton wedges, which is very popular, which they say that there are a variety of solutions. And the lowest hanging fruit, even remaining in fossilized domain, is to strive for energy efficiency and energy conservation as one of the measures to control this. Then, of course, hydrogen, natural gas, wind, solar, CCUS. These are some of the buzzwords and imperatives that each one of us are working. But what Indian Oil is doing, specifically being the largest oil marketing company, oil refining company, we have a clear-cut path within the fossilized domain to put out differentiated fuels in an otherwise commodity segment of fuels, fossilized fuels. These differentiated fuels, whether it is petrol or diesel, they would offer better fuel economy, thereby reducing the carbon dioxide emissions. In fact, those who are watching our company in the public space, they must have heard about the recent launch of 100-octane fuel very recently. I think this is the first ever 100-octane product in India, made available in India within the country. And also the lubricant space, Mr. Nitin also alluded to this fact that this is often neglected segment. People don't really realize the importance of this, but we have demonstrated along with some leading original equipment manufacturers, especially in heavy duty diesel segment, just by adopting right combination of lubricants in a heavy duty diesel segment, you can garner more than 4% of fuel economy just on account of change of lubricant. So these are some of the things that we are working within the fossilized domain. Of course, we are vigorously following the compressed biogas, the Satat scheme put forward by the Ministry of Petroleum and Natural Gas, Government of India. We are very active participants, both as technology providers for biomethanation of organic waste and also to offtake the compressed biogas that is produced by both public and private entrepreneurs who will produce this compressed biogas. You must also be following very keenly, this is the talk of the town of hydrogen CNG experiment that we are currently undertaking in Delhi NCR, where 50 buses we have converted them from CNG to hydrogen CNG without incurring any cost in creating dispensing infrastructure.
We are using the same CNG dispensing infrastructure that is available in Delhi, and we have just converted these 50 DTC buses from CNG to HCNG. And in HCNG also, we didn't actually took the path what other countries have tried in at various points of time. Physically producing hydrogen, storing it, and actually infusing hydrogen into the natural gas grid. We didn't go that way. We have a patented technology of partially reforming natural gas to straight hydrogen CNG mixture, and this hydrogen CNG mixture can then be dispensed. And the results are amazing. 3 months are over. Right now, these 50 buses are running, and both on the count of emission reduction and fuel economy, the results are extremely promising. And this project is being followed by no less than Honorable Supreme Court. We are also extremely active and cognizant of the fact that biofuels are one sure way of achieving the decarbonization, whether it is first generation biofuels, whether it is second generation biofuels. We are setting up 3 refineries, biorefineries, which will convert the lignocellulosic biomass to ethanol. And we had gone ahead a step forward, and we are setting up a very scalable plant of 33,000 ton per annum of ethanol production by using refinery off gases through biotechnological pathways. So this is coming up in one of our northern refinery locations. So this will actually convert the refinery off gases from the hydrogen generation units, the carbon dioxides and carbon monoxides, in a bio pathway using some select microbes, and it will produce the ethanol. We feel that this is going to really revolutionize in the pursuit of decarbonization by the otherwise fossilized industry like refining industry. We have also have very ambitious plans of running hydrogen fuel cell based buses, because we sincerely believe that the ultimate green mobility option is hydrogen. And no matter what is the color of the hydrogen, though chemically hydrogen doesn't have any color, but we have several colors to hydrogen. Even if it is a gray hydrogen, the very fact that hydrogen as a fuel into the fuel cell are in the internal combustion engine directly, the sheer lift in the efficiency of the operation will actually reduce the tailpipe emissions and the scope 3 emissions. So we are embarking upon running 15 hydrogen fuel cell based buses. We have just floated the tender, and for these 15 buses, we are going to set up 1 ton demo unit of hydrogen production from various pathways. 3 of them are green pathways. One is electrolyzer pathway. One is converting compressed biogas, green compressed biogas to hydrogen. And the third and the most promising one, as we are betting it, is on biomass gasification to hydrogen. And as Dr. Mathur was mentioning, if we need to achieve a break-even cost of hydrogen to that $2, so-called $2 scenario, if you want to really achieve, and we sincerely believe that the right gasification technology of biomass is the surest way of getting the most cost-efficient hydrogen, and a green hydrogen at that. We are adapting solar in a big way. I must share with you that out of 30,000 retail outlets of Indian Oil, 18,000 retail outlets are completely solarized today. And apart from these retail outlets, at various other Indian Oil locations on pan-India basis, we have 150 megawatt installed solar capacity, and it is growing by the day. We also believe in e-mobility, because not one single solution is going to really take us to the ultimate decarbonization scenario. So battery technology also we started working, and somehow we believe that lithium chemistry is not the real solution for India. So we are looking for alternate chemistries where the raw material is abundantly available within this country. So we are looking at alternate chemistries like aluminum and zinc. We have a tie-up with an Israeli startup company, and we are going for manufacturing units of such kind of batteries. Some integration and homologation validation trials of these alternate chemistries we are undertaking along with some leading automakers here. So put together, Indian Oil is very conscious about the energy transition and need for decarbonization. And remaining in the fossilized scenario, we feel that at least 50% of our business in the next 10 to 15 years should come from renewable energy sources. Carbon capture and utilization is one of the last initiatives I would like to share with you. We are working that the carbon capture costs, the global benchmarks are today they are standing at $50 per ton. But if we want to make these CCUS technologies affordable and implementable in Indian scenario, then the cost of carbon capture need to be brought down to at least $25 per ton. So we are working in that direction as well, and we are working again both the chemical pathways as well as enzymatic pathways, and we also have some revolutionary concepts with us where we can convert carbon dioxide, the captured carbon dioxide, into lipids and highly value-added omega-3 fatty acids or DHAs, which will actually cross-subsidize the entire cost of carbon capture and utilization. So these are some of the projects, and we are extremely conscious about these kind of energy transitions, and we would like to remain in contention even in the transitional scenario, being the conventional oil marketing company, oil marketing and refining company. I would stop here and would be happy to share some more when the panel discussion starts. Thank you very much.
Sir, please unmute yourself.
Thank you. I thank you, Dr. Ramkumar, and I think IOC's large-scale efforts towards using biofuels on the one hand, alternate chemistries on the other, and trying to figure out how CNG and CNG to hydrogen, how these various options could make sense, both in terms of their usage as well as in terms of their economics, presents up to us a huge lesson in the way companies would work towards finding solutions. Let me now turn to Dr. Devishesh Bhattacharjee from Tata Steel and request him to share his thoughts with us. Devishesh, I know you were delayed because you were in a meeting that you could not avoid, but many, many thanks for joining us.
Thank you very much, Dr. Mathur, and thank you for inviting me here, Amit and Dr. Tapan Chaudhary. I'm grateful for giving me this opportunity. It's a great platform that I'm sharing with very knowledgeable people in the area of energy transition and hydrogen. So let me, a lot of the background has already been spoken about, and so I will not repeat what has been said. I will rather focus on what is important for the steel industry and therefore for the nation, and what efforts we are at this moment undertaking to address these issues. So as you know, steel industry worldwide is responsible for about 6 to 8%, depending on how. Can you hear me?
So we can hear you.
Yeah, okay. Right, okay, so let me continue. So steel industry is responsible for about, say, 6 to 8% of the man-made CO2 emissions worldwide. And most of it comes out because we are reducing Fe2O3 essentially to Fe. and the most convenient reductant is carbon, right? So if you do a theoretical thermodynamic analysis, you will find that if you use carbon as a reductant, you will give out, the steel industry will give out about 1.6, 1.8 tons of CO2 per ton of steel produced. So of course, people find it difficult to work at the thermodynamic limits. Kinetics doesn't allow. So roughly the Indian output, the more sensitive and advanced blast furnaces, blast furnace being the equipment that reduces iron oxide to iron, give out about 2.5 tons of CO2 per ton of steel. Now imagine the world produces about 1.6, 1.7 billion tons of steel. Multiply that by 2.5 as an average, and that's a huge number. India today makes about 110 million tons of steel. So that's in excess of 250 million tons of carbon dioxide per year. India has an ambition and the need to go to about 300 million tons of steel per annum. So that would be 700 million tons of carbon dioxide to be handled per annum, right? So that's the scale we are talking about. And as Nitin and Dr. Ramkumar have already pointed out, technologies today don't exist at that scale. There are many technologies at various TRL levels, but to address CO2 at that scale, it will need time. But we need to start. So this is the approach that we are taking, especially in Tata Steel, and most of the steel companies follow the same philosophy. There are two paths. One path is to reduce the CO2 emission itself. So therefore, you take for granted that there will be a blast furnace. You take for granted there will be carbon used and CO2 emitted. So capture that CO2, make use of that CO2, or sequester it somewhere safe. Now, our European plants in Netherlands or UK have a favorable geographical location. They can capture the CO2 and they can put it in a pipeline that's a national pipeline for CO2, which can take the CO2 down into the North Sea and into exhausted oil wells. Nitin is fully aware of those initiatives. Some are at a smaller scale today, but there's a huge national initiative to take it to a large national scale. So we can, in Europe, we can ride that way. In India, unfortunately, there are no appropriate geographical locations to sequester the CO2. So we have to find a utilization solution, either through ethanol or through producing a chemical which is economically viable, and so on and so forth. So long chain organic molecules, some of them Dr. Ramkumar just alluded to. So this is the approach today, where we are using an amine technology predominantly for capturing CO2. So we have a pilot plant set up in Jamshedpur, a small pilot plant, which will then be upscaled by a factor of 100, 5 to 500 in our Kalinganagar plant. The issue is we will get used to capturing the CO2 that is coming out of the blast furnace, which is only 20% rich in CO2. Therefore, handling that gas, handling the temperatures, will need some time to getting used to, and then we'll parallelly talk about and work on how to utilize that CO2. Some of the CO2 will be utilized in the plant itself. We actually buy CO2. Can you imagine? Steel plants buy CO2 to treat water. So hopefully we will reduce cost when we capture this CO2 and that's made available. And so that's one part, how to capture the CO2. But we will eventually be limited by utilization potential of the CO2. Right. So the second route forward, which we are parallelly considering, is the manufacture of green hydrogen and utilization of the green hydrogen. So it has already been alluded to. There are multiple ways of generating green hydrogen. Of course, in the West, green electricity is available on the grid, and therefore the Scandinavian countries, Germany, they can produce hydrogen through electrolysis, and that would be green hydrogen for them. Not so in India yet, and it probably will take another 10-15 years before significant part of the industrial electricity becomes green to produce hydrogen that can be used in a steel plant at scale. So we are not, while we are progressing with the electrolysis in the eventual hope of the grid electricity being green, we are also trying other sources such as biomass, municipal waste. Biomass having a short CO2 cycle can be considered green. We are also looking at chemical routes. We are looking at chemical looping technology, where you use FeO and you convert the CO through a water gas shift reaction to CO2, and you generate hydrogen, essentially. And that would be a captive solution for us, because the FeO is ours, and therefore a favorable price point. Coming to the price point, today hydrogen would be for industrial purposes, not for automotive purpose, where you need very pure hydrogen. Luckily for the steel industry, we don't need that pure hydrogen. We could deal with 95, 90, even 92% hydrogen for our furnaces. The price point today is about anywhere between $1 to $2. Yeah, we aim to bring it down to $0.5, and that would then be quite viable for the steel industry today. The other part is the utilization of the hydrogen once you've produced it. Of course, the easiest solution is to put that hydrogen into the blast furnace, but that has another technological limit, and you can by this process you can bring down the CO2 emission from the current 2.5 tons per ton to about 1.8. You can't attain zero, and that's our aim, to go to as low as possible. And although we have not declared zero target yet, but that's our internal aim. So we have to change the technology itself, where it can be 100% hydrogen-based technology. So we're looking at direct reduced iron, where gas-based reduction of iron, and the gas would be hydrogen. Today, gas-based reductions use liquefied natural gas. So a step forward on that would be to take the carbon out of the natural gas and just have hydrogen. And hydrogen can be sourced by the technologies I've just spoken about. We are working with two of the bigger manufacturers of these gas-based direct reduced iron units to tailor our raw materials for those technologies for using 100% hydrogen. And of course, then you will not need the basic oxygen furnace, which is very commonly used with blast furnaces. You would use the reduced iron you would put that into an electric arc furnace. So we see the future of steel making changing. We see blast furnace BOF route, which is roughly 65-70% of iron making today, slowly changing to gas-based, hydrogen-based DRI, or even predominantly gas-based DRI, direct reduced iron, that is, plus an electric arc furnace. So that shift is going to happen over the next 10-15 years, and maybe it will take another 20 years before the steel industry becomes close to net zero carbon. So with that sort of a picture, let me come to my concluding comments, which are the following. As you can imagine, we are handling huge amounts of gases, millions of tons. A steel plant of 10 million ton capacity would have 25 million tons of CO2 to handle if you're just going by the CCU route. 1 million ton of iron to be reduced needs about 60,000 tons of hydrogen. So these are not core competencies of a steel company. Yeah, so we will need collaboration with companies which are adept at handling gases like hydrogen, and we'll need other companies, companies like petrochemical companies which have already made progress in these areas. And we are already working with some around the table here. So, and of course, none of the technologies provides full solution. So there will be need for collaboration with academia to come up with new technologies going forward. And of course, you need policy help to enable these technologies to be put in place. These are expensive technologies. Steel is not going to be any cheaper when you put these technologies in place. So this would need policy intervention for the industry itself to be encouraged to go towards zero net carbon. The automotive industry is front facing it. Consumers see it. Materials industry is in the background. People don't see it. Yet they would need such policy support that Mr. Lal was talking about a little earlier, also in the basic materials industry. So with those comments, I will say thank you again for giving me the opportunity to speak. Back to you, Dr.
Thank you, Devishesh. This was amazingly interesting. I'm so glad that you got into the details, both of the amine-based solution as well as the longer hydrogen-based solution, because it tells you that there are both shorter term and longer term strategies that are essential to be part of the transition. I know we are already over 12. Shonali and Amit, who I hope would bring this discussion together, has yet to speak. Shonali, can we go on to say till about 12:15?
Yes, sir, no problem.
Okay. So Amit, can I request you amongst the company CEOs to for the last word on specifically what I'm asking is, can we put these things together?
Thanks, Dr. Mathur, and thanks everyone for joining this webinar. Thanks, Rajnath Ramji, Nitin Prasad, Dr. Devishesh, Ram Kumar, and Ajay Loyal. I think in everyone, almost 500 of you, passionate disruptors, innovators attending this webinar. I'd like to first thank, and then I'll try to demystify a lot of the stuff that we've talked about. I think we are amidst a great transition period, a very exciting time for engineers, innovators, and disruptors. And while some call it an era of sustainability, green, climate change, and some call it fourth industrial revolution, etc., I think what's very also important that the current pandemic has given us a realization of our responsibility to the environment. And I think the underlying theme is indeed a better appreciation and responsibility towards future generation and respect towards the planet and the resources. Now, another aspect of this entire transition is not just purely climate, but it's also about the volatility, the economic cycles becoming shorter, and the basic demands of the so-called developed nations, luxury expectations versus the rest of the world is normalizing. So we don't have these siloed approaches where you had wealth concentrated. We're pretty much having it across the globe, which means that the so-called equalization is exponentially increasing the negative impact of growth on our industrial plants and future sustainability. Well, energy and resource indeed drive growth. And what's interesting is the resources are undergoing through a fundamental shift. The so-called exotic metals we had are in demand today. So the whole periodic table focus is changing for, say, the miners and the material industry. And the second part is a very interesting contradiction. We as humans have worked with high density energy sources. And suddenly we are grappling with low density energy source and trying to figure out how to densify it by storage, transmission, and distribution. So that's the challenge for engineers and our clients that we work across industry. And I'll try to connect the dots with various industries because this transition is not going to be siloed in one area. You can't have automotive players without the chemical players and hydrocarbon players, the steel players without the hydrocarbon. You cannot have the same competencies of people working in these industries. For example, you need probably more electrical and chemical engineers in the automotive world, and so on and so forth, the logic goes. Now, before I put up my point on the framework that applies to the industries we work in as consultants, we must truly understand energy transition is not just alternate sources of energy, but actually rewiring and understanding the flexibilization, as Nitin talked about, to really meet the demands which are varying, because we are moving from a push-based model in the value chain to a pull-based model. And the pull-based model means customers will demand innovations and you have to work in collaboration. So there's a big shift from the traditional mass production push to a very nimble, configurable, flexible pull demand, right? And it works across all industries and value chain. But when we look at this transition path, not just on energy density and the issue of intermittency or continuity on the other hand, we need to also look at the entire footprint of the carbon footprint. And for example, while hydrogen has the highest energy density at about 120 to 150 gigajoules per ton, which only nuclear beats, the issue with hydrogen is of course volume, right? And the same logic goes in terms of solar. You would need 5 times more solar with load factors which will never compare the base load of thermal plants and the whole land availability, including biofuels. Do you need this land for food or do you need the land for energy? And that's a mix that one have to be very carefully in a socially active and environmentally conscious world rethink about. And I just want to put up some questions because of few of our young innovators on the webinar. It's the curiosity of the engineers and the industry that will drive this shift. Now, aluminum, for example, is lightweight material for the automotive industry, which needs to embrace it because of adoption of EV or FCEV. But to produce aluminum, you need close to almost 6 times the gigajoules that you need to produce iron. At about 300 gigajoules per ton, aluminum is much more negative carbon than steel at 50 gigajoules. Copper, of course, is in the similar range of 100 gigajoules. But hey, PV is at about 7,600 gigajoules per ton for production of electronic grade silica. So when we look at PV in solar, or we look at the large wind turbines, we look at EV vehicles, and we look at the change in the hydrocarbon industry, we must map out the carbon footprint across the value chain and inter and intra, because the value chains will blur the lines and the boundaries. And while we can look at the initial journey of this transition in a siloed or a bolt-on or an alternative manner, eventually we'll have to be conscious to understand the connects between these. So I think there are 3 critical points: the energy density and grappling with densifying the low energy that we are looking at, low dense energy. Second, the whole integration, flexibilization, and the transmission distribution, whichever industry you are in. And finally, the overall carbon footprint across scope 1, 2, and 3, as the industry puts it. So talking about value chain, of course, it gets a bit confusing sometimes, but case in point being, as I said, as Nitin talked about, the hydrocarbon industry has to work with downstream players in steel. The automotive will have to work with upstream in steel and aluminum with chemical companies. And so the ongoing transition must involve early sight of TRL 1, 2, 3 technologies. You should not look at this transition in what you have today, but your roadmap should align with the TRL levels that the academia or our collaboration with industry through active support of policy and government initiatives can provide. And this is the best time for the innovators to really come out with breakthrough technologies. And the TRL levels have to align for the next 2 years, 5 years, 10 years, and we must be optimistic that the TRL levels will catch up with the roadmap. It took 50 years for oil to get 50% tipping point from wood and coal, and it took almost 100 years for oil to become predominant and coal and remove wood completely. So transition are not about 5 years or 10 years or 20. I think if we are really smart, miraculously, we can get to low carbon or zero carbon in 30 years. Realistically, the pundits call it about 70 to 75 years. And of course, the alignment with the TRL levels in the labs and the academia and the industry partnership is very important. So, and while we're doing that, the biggest challenge is economic cycles. So the ROIs cannot be calculated in 20 years payback. while we change the and we work with the hybrid approach, whether you're in power, hydrogen, steel, hydrocarbons, automotive, you'll have to marry the old world with the new world, right? So this hybrid grid has to work together to make sure that seamlessly we integrate the brownfield, old existing legacy and sweating them and adding the greenfield. And that's where the enabler with digital and Industry 4.0 comes in, because without this glue and rewiring your plant understanding, you can't really marry the old with the new. Now, so as consultants, when we look at our client issues and their visions and plans, whether you're in hydrocarbons, steel, automotive, we try to abstract certain elements of the journey which are agnostic to the industry. And we build upon those experiences together. Let me give you an example. While energy transition may start in respective value chain, the true efficiency will only happen once the value chains interconnect with other value chains. And I think many of the speakers talked about it. Carbon footprint analysis truly has to be understood from scope 1, scope 2, scope 3. Modernization, of course, is inevitable, and the new technology will gradually integrate. We need to understand the gas balance, steam balance, energy balance. So there is maths behind this, which has to be done. And at step 1 or phase 1 can be scope 2 and a bit of scope 3, but then you'll have to rewire your enterprise and get the efficiencies gain. How do you pay for this transition is very important, is to get your efficiencies up. Looking at policies and incentives may be a short-term catalytic approach, but in the long term, subsidies, offsets, or penalties will not serve the purpose. So ultimately, industries will look at efficiencies while they rewire and look at low carbon technologies. As an example, there are efficiencies. In automotive, people have realized that instead of 10,000 moving parts, if it can come down to 500 moving parts with electric vehicles and FCEV, the natural efficiency gain will happen, if not in 2 years, into 5 to 8 years, right? The number of supplier base from 27, 30,000, reducing to 1,000 with a completely new model will give you those benefits. But product flexibilization and the pull model will demand rapid innovations. And that means your variance would increase your investments and the life cycle of your products will be much shorter. So if I, as a consultant, working with our clients and industry pioneers and research institutes, as in TERI and academia, as I say, put into a framework, we call it simple ABCD. A is your input. B is what you work on internally in your plant. C is your output. And D is your circularity or recycling. Without giving any exotic names, A, B, C, D, right? Input, what you do inside your ecosystem, what we call as scope 2, scope 3 as output, and the circularity. And it's very important as we talk about circularity, because a lot of your ROI payback can only happen if you look at a minimum circularity in your value chain. For example, steel recycling must become a norm rather than a fashion statement, or automotive body in white recycling must be an integral part of the strategy, so on and so forth, where it applies to consumer goods, hydrocarbons, industry, etc. Now, what are the elements of this ABCD cycle? Well, A, that means the input could be green. Whether it's too green today, pre or post production, time will tell. We need to look at the TRL levels. Dr. Devishesh talked about that. We need to look at the energy density and its alternate sources of production. Per capita, let me take an example of infrastructure. Is metro and high-speed rail going to give you a better energy utilization? Absolutely. Is it part of energy transition? Absolutely. So the per capita energy in terms of land, people, weight, energy footprint will all help us determine the right story in the A part. What about B, which is operations? Well, it's all about efficiency, but more importantly, efficiency under varying loads, be it in power, be it in oil and gas, be it in steel or other metal industries or automotive. Efficiency will have to be redefined in terms of varying load versus constant peak production of mass production era that we worked during the push regime. In the pull regime, efficiencies will have to be defined, and you cannot reach these efficiencies unless you rewire the plant using digitalization, using smart sensors and enablers to look at the balance required across the subsystem level and the overall system level. Finally, product mix will change. So your supply chain, your vendors, your partners, upstream and downstream in scope 1 and scope 3 also changes. Lastly, the interconnectivity of these A, B, C, D will be a critical part of your strategy in a holistic manner, right? And it will fundamentally redefine the way you look at business today versus the way business is run tomorrow. So the whole financial economics, energy economics, recycling economics, the operational economics will require new KPIs, will require new dashboards enabled by digitalization. Of course, in all industries, we find 4 common challenges: intermittency, low power density of alternate areas, integration requirement to match the volatility and predictability of demand, and lastly, the financial backing and the business case. Many of the early innovators struggle with the business case. And as I said, while we need policy and incentives, the only way to master is through collaboration, because we can't solve the problem in our own area separately. And I think this is a great time for India under the Atmanirbhar Bharat campaign to also encourage the young innovators right at the academia level, working with the industry with support from government to do certain pilots, experiment. Unless we fail in 10 experiments, we wouldn't succeed in the next 5. And so there has to be a boldness in our youth that has done successfully benchmark global performance as regards IT, but now the true engineering of the physical world and the rewiring of the enterprise provides an immense playing ground, which would be a delight for the engineers. Now, to demystify energy transition, I pick up infra. What can be done in infra apart from material? Can we look at modular buildings? Can we look at precast and prefab? Can we reduce the transportation of material to sites using precast prefab? That will have between 3 to 6% impact on carbon reduction purely by just doing this change to a modular building information model based. What about additive manufacturing? We'll have buildings coming up with additive manufacturing. How come additive manufacturing with metals and cement both change the whole dynamics of energy transition? Can we look at energy transition in terms of input, but keeping the gigajoules maths in mind? Aluminum, silica, copper, as against steel, what's the true carbon footprint? In terms of operational efficiency, I believe this would be a step 1. Before any rewiring happens, we truly need to understand the new dimensions of operational efficiency, KPIs and dashboards. And as I said, digitalization efforts must be a strong enabler for your strategy on the energy transition, which of course few of the panelists talked about. Demand side measures on the scope 3 are very important. Justifying gray, blue, or plain vanilla hydrogen, for example, is another matter that Dr. Ramkumar talked about. My last point would be, when you're rewiring, collaboration is a must across upstream and downstream in your value chain, and we must look at holistically. So to summarize, the ABCD model, whether you're a student or an industrial pioneer or in government policy making or research, the ABCD is the simplest thing, can be applied to subsystem, system, and at plant level across all industries. Look at the maths in input, look at the maths in the operations, look at the maths on output, and ensure there is circularity of some shape and form. Unless, if you don't do that, the business case will always be challenging. Align this roadmap to lab scale. Look at the pioneers working in the research labs, look at the TRL levels, and be optimistic that they will change. We didn't have the first oil and gas fields in deep sea till about 50 years after we figured out how to extract oil from land. And so I think with the current innovation across the globe with multiple value chains, we can do it much faster. in the new energy transition era. A startup ecosystem is very important with pilots and experimentation, because we in industry sometimes are afraid of failures. But I think it's very important with the CSR funds being able to put in academia. We, for example, have partnered with few research institutes to look at these experiments and pilots within the Institute of Sciences, IIT Bombay, of course, working closely on thought leadership with TERI, and so on and so forth. Last but not the least, it's an exciting time for engineers. It's a playground rich with possibilities, and your imagination has no boundaries. But energy transition is not an easy approach. It'll take minimum 30 to 50 years for you to change the needle from 90% fossil still to say 50% or lower by 2050. With that, thanks, Dr. Mathur, and back to you.
Thank you very much, Amit. I found it amazingly useful to look at your ABCD model, which kind of encapsulates what everybody else said. And your point about, this is a point that has been made by several people, that collaboration both upstream and downstream is important as we look to the future. You help your clients design new products, and you work with your suppliers to see what is it that you need. The other point I think I'm carrying away is the need for a time-based strategy. There's something that you do now, there's something else you do tomorrow, there's something else you do day after. But you need to have a roadmap in place today. And I'm glad that many of you have brought this out. The third point, and Amit, both you and Dr. Ramkumar focused on, was that efficiencies are still important, whether it is through resource efficiency, the recycling, or its energy efficiency. They become important as part of the transition. They also become important, as was mentioned, I think Devishesh mentioned it, they become important when you're looking at paying for the transition. I think that, like all discussions, this was immensely fascinating. It could have gone on. We have gone on a little longer, but I'm so glad that we were able to get from, in a sense, the leadership. What is it they are grappling with? How are they addressing these issues? So, thanking the panel for its interventions. Let me now turn it over to Tapan Chaudhary from TCE for the last comments. Tapan.
Running short of time, so I will not take much time. I have actually found out that couple of points, I think bullet items, which have been spoken by all of the leadership team. That is technology, innovation, economics, policies, flexibility, collaboration, digitalizations, and then drawing up a separate industry structure as a whole to accelerate the process. And overall, the overall thing which is coming, that the collaboration is a must in terms of research institute, academia, as well as all the industry leaders, what has been spoken in summary. As an organizations, you know, the way our Amit has spoken, we actually demystify, and for which we create a roadmap across the industry. With all this, I am really taking the great honor to propose the vote of thanks, and I think I would like to propose vote of thanks to our guest speaker, Sri Rajnath Ram, for gracing today's webinar. Thank you, sir, for giving the policy and the Atmanirbhar Bharat as a whole. I would like to express my sincere thanks to all the other speakers, starting from Nitin Prasad, Ajay Lal, our Dr. Ram Kumar and Dr. Devishesh for sharing their best practices and the way forward. I would like to thank Dr. Ajay Mathur for helping us for organizing this, as well as giving us guidance for giving such sort of a panel discussion in future. I think, sir, I think you have given 10 points, which I have noted down for our future path. And finally, Amit, you have given that it is an exciting time for all the engineers, because we are going back to the basic sciences and basic periodic table understanding as a whole, and which will give us a path for forward and doing a lot of other things to do, which actually give a roadmap to the future. Finally, we express our sincere thanks to our colleagues for TCE and TERI who make this webinar a grand success. And we like to thank all of you, and we want to conduct such seminars in future to bring, because this is the beginning of the journey, and we like to go ahead with this journey with full force, and we hope that we will get all the cooperation. Thank you, Dr. Mathur. Thank you, all the panel members. Thank you so much for being with us and the participant and the attendees. Thank you so much. Thanks.
Great pleasure to have been with everybody.
Thank you, Dr. Mathur. Thanks, Nitin, Devishesh, Ram Kumar, Mr. Lal. It was great to hear your thoughts, and we'll catch up soon.
Yes.
Great.
Thanks, Ahmed.
Thank you, Dr. Mathur.
Absolutely wonderful. Absolutely.